Lithium battery prices have come way down in recent years, but some of the batteries are so inexpensive you kind of wonder, is it too low? Should you be spending a little bit more? And today, with that in mind, I'd like to introduce the LiTime Trolling Motor battery. I recently held a live event and I just needed some inexpensive batteries that I could put into my system. I had already spent so much money on the rest of the electrical equipment. So I reached out to LiTime. I asked them for the Trolling Motor Edition batteries, and today we are going to test them out. I'm not going to tell you whether this battery is good or bad. By the end of the video, we are going to run it through several tests, and you're going to be able to see how it does with each test. We're going to do charging, discharging, a low temperature shutdown, and more. And what we're going to do is look at the screen here. This is pulling data from the smart shunt that we have in the negative line. And we're going to pay specific attention to the current. So this battery is supposed to put out 100 amps continuously as a maximum. It will also surge to 300 to 500 amps for 5 seconds for those surge situations. This is a special feature of the trolling motor variety. Which, by the way, I don't have a boat or a trolling motor, but I like the features of this battery for a van or RV because it has that surge capability. It'll allow you to go over and overload it for 5 seconds, 300 to 500 amps. And it also has low temperature shutdown. So as you would expect with the trolling motor, it's made to be used outside. And if it goes below freezing, it will not accept a charge. Supposedly, we're going to test that out. But those are the two features, the overload feature and the low temperature charging shutdown that the trolling motor battery has. And I really like those features. And it's a little bit more expensive than their basic 100 amp hour lithium battery. But to me, that's what every battery should have. Even if you're in a mild winter climate like I am here in Houston, Texas, you still want that low temperature charging shutdown because you may travel somewhere really cold, turn on your charger accidentally and damage your battery. So to me, we've already got that battery management system in the top of the battery. You might as well have that low temperature shutdown that frankly all the more expensive batteries already have. So that's the trolling motor battery. At this point, let's go ahead and do our first test. So I have the MultiPlus on over there, and we've got 1.26 amps coming out of the battery to run the MultiPlus. And we've got 3 1,000 watt stoves. I'm going to turn on one stove and we are going to look at our readout. This is our first discharge test. So we're going to turn on the breaker. That powers up this. I'm going to turn on stove number 1. And you can see we've jumped over 90 amps. The negative means a withdrawal. So we are pulling out over 90 amps from the battery. And in prior testing, I could tell you that that will run for an hour until the battery is completely flat and shuts off. So it will easily run the stove. Now, in order to test the 100 amp, it's supposed to put out 100 amps continuously. As you can see, these are going to be pull 90 amps each, 180 amps. We need something a little bit smaller, so I've added this little battery charger, and I'm actually going to set up this other battery as a variable load, and we're going to pull about 9 more amps out of it and see if it can handle that. So hang on tight. All right, it's getting a little bit toasty in here. What I'm going to do is plug the charger in all the way, and it should turn on, and it's already set up to pull about a certain amount of amps. Let's see. So actually I kind of overshot it a little bit. It's at 114-ish amps. And this is supposed to put out 100 amps continuous. So we are overdoing it, and I'm just going to see how long the battery lasts. All right, it's been about 5 minutes. You can see it's still pulling 115, 116 amps there. And you can see the battery is starting to heat up. I've got a temperature sensor on the smart shunt connected to the battery. So it is getting a little bit toasty, but it is holding steady for a full 5 minutes here. And you can see on the wattage, we are at 1400 watts. So we are well beyond the stated output of the battery. So far, pretty impressive. All right, so we are still holding steady at 115 amps. Let's go ahead and shut this test down. But it is 9:59 a.m., started at 9:52. So it's been about 7 minutes of basically putting out 115% of what it's supposed to be. And we are at 111 Fahrenheit. So this temperature sensor here to go into the smart shunt is, the battery is definitely heating up a little bit, but we are definitely overloading it. So let me get this battery out of the way, and we are going to turn on all 3 stoves, and we're going to go into the overload scenario and see what happens. All right, our battery has cooled down to 81 degrees Fahrenheit. So we are ready to do our overload test. What we're going to do is go ahead and turn on all 3 of our stoves to max power. Now our breaker's off, so they can't get any power. What we're going to do is turn on the inverter charger, let it crank up. It's going to pull 1.25 amps approximately. And we are going to overload. So it's supposed to go 300 to 500 amps for up to 5 seconds. Let's see what we've got. 1, 2, 3, 4, 5. I think I jumped the gun on starting my count. So it was about 5 seconds. And as far as the overload current, let's go ahead and track that again. I believe it's about 340 amps. What's going to happen is it's going to shut down. We've actually lost power here. And it's going to restart after about 15 to 20 seconds. So that's a nice feature. It looks like it is coming back on. Okay, inverter is back on. And this is getting a reading again. So it will restart after it does the overload shutdown. But let's try it again and look at our current. 342. So it went about 5 seconds, 342 amps. So I would say that is definitely a pass on the overload test, and allows you to get those overload situations. But it's not going to go beyond 5 seconds, because if it did, it could get hot and then it could start a fire, and now we have larger problems. So it gives you a little bit of overload, but cuts it off after 5 seconds, which is perfect. So let's go from discharging. Let's do a charge test now. Actually, it's restarting. Let's turn these off. We're going to do a charge test. It's supposed to allow up to 100 amps continuous charge. Now that's a maximum, supposedly. The recommended charge rate is 20 amps per 100 amp hour battery. Now, it also talks in the manual about charging it at 50 amps. 50 amps for a 100 amp hour battery is the kind of industry standard charge rate for lithium. They're asking you to do 20 amps, which is a 0.2 C charge rate. That is double that of lead acid, but it's a little bit low for lithium. But in order to get the 4,000 cycle life out of the battery, it's supposed to do 4,000 cycles at 100% depth of discharge. In order to do that, you would typically follow the recommended charge rate of 0.2 C or 20 amps per 100 amp hour battery. Like I said, it's a little bit low. Nobody really wears out these lithium batteries, especially in a recreational vehicle where you're not cycling it constantly every day. So if it were me, I wouldn't. I would charge it at maybe 50 amps per 100 amp hour battery, but you're going to avoid the warranty like that. It's up to you. That's the only complaint I have about this battery. Putting 20 amps in a 100 amp hour battery is a little bit low, and what that's going to translate to is more time. It's just going to take you from completely empty, it's going to take you 5 hours to charge this. If you charged it at 50 amps, it would take you 2 hours. So it's just going to be a little bit slower charging process. However, for our test today, we are here to max it out, right? So What I'm going to do is try to put 100 amps in the battery, and we're going to see if it can accept that for a prolonged duration. And the way we're going to do that is go ahead and plug our inverter charger into the wall. We're going to bring in our power grid. And I'm going to zoom in here in just a second. That's going to detect the grid power. It's going to turn on its charger, and we should see about 100 amps coming into the battery. And we're just going to see how long it can take that. All right, so we can see the charger adding more amps into the system. We're going to let this run for a few minutes. You can see it's going to level out right at 100 amps, which is the maximum that we're supposed to charge this battery at. And I just want you to notice the time, 1:35 p.m. Yes, these videos take me all day to film. I started at 10 a.m. But we're right at 100 amps, and I'm just going to let it sit there for about 5 minutes, and we're going to see if this battery can actually sustain this 100 amp charge rate. It's now 1:40 p.m. and it's been about 5 minutes. The battery has sustained the 100 amp charge for 5 minutes, and it has definitely passed the test. All right, so we have one more charge test to do, and that is the low temperature charging test. It's not supposed to accept a charge below 32 Fahrenheit. The way we're going to test this is I'm actually going to take the battery out of this setup here. I'm going to throw it in the freezer for a little while. We're going to get it below freezing. We're going to bring it back, reconnect it. We'll be able to check the temperature with our temperature gauge that we have here with the smart shunt, and we're going to see if it takes a charge when the battery is below freezing. So while we're waiting on that battery to freeze, I wanted to tell you about a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It actually has a discussion about different battery types, internal BMS versus external BMS. BMS is battery management system. Internal BMS would be like the battery we're looking at today, and how does that compare to an external BMS battery system, and which one would be right for your situation. So that is discussed in the cheat sheet. Also, there's a discussion about 3 different charging sources that you're going to find in van and RV power systems, which are solar, shore, and alternator power. And it's going to talk about how they each have strengths, but they also have weaknesses as well. But when you bring them together in a holistic power strategy, it's going to make sure that you're covered in any scenario you find yourself in, so you can enjoy what you went out there to do, and you're not going to be worried about running out of power. Lastly, there is a really cool diagram that's going to show kind of what you see here. It's going to show your charging sources at the top, how that power makes its way through to charge your battery bank, and then how that power gets distributed to your end devices such as your electric stoves or your cell phones. So it's a really illuminating diagram. If you're not quite sure how these systems go together, I think you'll get a lot out of that particular diagram. All of this is part of the Van Power cheat sheet. To get your own copy, all you have to do is click the link below or go to rosslukman.com/vanpower. All right, with that, let's go ahead and check on the battery and see if it's gotten cold enough. All right, so we've got the battery back in place. The MultiPlus is plugged into the wall, and the charger has been reprogrammed and turned down to just 20 amps. We're not trying to kill the battery. We just want to see if it takes a charge. But we're currently at 0 amps. What I'm going to do is hit the switch to turn on the MultiPlus. It should detect the power grid and try to turn on its charger. It looks like it is drawing power from the battery, so the battery is putting out power. It's supposed to put out power down to -4 Fahrenheit. which is negative 20 Celsius. The charger is going to try to turn on, and it is going to be unsuccessful. Basically, the battery did not accept a charge because it's below 32 Fahrenheit, and the charger was not able to put any power, so it's going to go ahead and go into absorption mode. It thinks that the battery is fully charged because it could not get any amps into the battery. So it has passed the low temperature shutdown test. Now, as far as charging, when the battery warms up to 41 Fahrenheit or 5 degrees Celsius, it should accept a charge again. So as it heats up here in the ambient air, if I just left it as is, it's going to heat up because it's way above freezing in this room. So eventually it would hit 41 and accept a charge again, and that's all automated. I wanted to give one more detail on the low temperature shutdown. So it won't accept a charge below freezing, but it should discharge down to negative 4 Fahrenheit, negative 20 Celsius. So currently the battery is above that threshold. It should put out power, but what I've discovered is it won't put out full power. If I try to run one of these stoves, let's turn that on. The inverter, which is unplugged from the power grid, so it's pulling power from the battery, you can see it click there. It tried to run the stove, but the battery shut it off after a few seconds, basically that 5-second window, and it would not put out the full 90 amps to run one of these stoves. However, what I discovered is if I turn off the stove and I plug in this light, which is about 25 watts, when the inverter tries again, there we go. The light operates, and we're pulling about 2.5 amps. So we can't pull 90 amps, but we can pull 2.5 amps from the battery. So as it warms up, it will enable itself to put out more and more amps until it reaches room temperature, and it'll allow you to pull out the full rated power, or 90 amps for this stove. Full rated power being 100 amps. But I just wanted to point that out. So you can discharge it, you just can't completely discharge it at the maximum rate of 100 amps while it's frozen. So just something to note. To wrap up, I wanted to mention that I did run a couple of capacity tests on the battery to make sure that we had 100 amp hours in there. I got 100.5 amp hours during my 20-hour discharge test and my 10-hour discharge test. So basically, I drew 5 amps out of it for 20 hours or 10 amps out of it for 10 hours. And the CBA, Computerized Battery Analyzer 5 from West Mountain Radio, it graphed the voltage of the battery until the battery completely disconnected and cut off. And as I said, 100.5 amp hours on either test. When it came to watt hours, it's supposed to have 1280 watt hours. I clocked it at 1304 and 1309 in the various tests. So it is between 100.5% of capacity on amp hours and about 102% when we look at the watt hours. So either way, no matter what test I hit it with, it definitely passed, and it had the capacity that it was supposed to have in there. And I just want to mention also, I did not expect to rave about the manual, but I really enjoyed the manual. They talk about how to hook it up if you're dealing with solar, or how you're going to hook it up with alternator power or shore power. They went through a few scenarios in there, and I won't bore you too much with the details, but I was really impressed with the manual. Some of these products, the manual leaves a lot to desire, but I thought they did an excellent job explaining the battery, how to use it in different scenarios, how to wire it up in series or parallel to make larger battery banks, things like that. So definitely check out the manual if you purchase this battery. And if you'd like a discount, there is a discount code below. It does also go to support this channel. But I really recommend this battery. I tried to break it. I tried to run it through every test and get it to fail, and I felt like it really stood up to everything I threw at it. And I'm pretty impressed, especially for the price. It's very hard to beat this battery. So highly recommended. And that is my review of the LiTime battery. Again, if you want help with your overall power system, not just your batteries, you got to grab a copy of the Ultimate Van Power Cheat Sheet. Just click that link below or go to rosslukman.com/vanpower. So thanks for watching, and I'll see you in the next video.